construct an equation of the main trio of self-similar dendrite. And this is a dendrite called Hata tree. It appeared in the paper. There were two Hata trees, and this one appeared in the paper of Masayoshi Hata in, I remember, 1985. It's quite old. So the problem is to construct this dendrite, and second, to find its main tree. So first problem is what is the self-similar boundary of this dendrite? So there is one intersection point, just one. But if you consider its pre-images, then you will see that this point is a pre-image of this point is the pre-image of this point, this point and these points are also pre-images of this point, so the main tree will be something like that. I don't know how it looks. Okay, so we can only imagine how it looks like. But first of all, we need to find the parameters for such trapezoid so that the union of its two copies would intersect in this point. Can you find the parameters? Not very easy. So we suppose that it is, say, 1, 0, 1, and then we suppose that this is angle is alpha. I'm not sure that every alpha will fit. So what it will be? Can we write an equation for this trapezoid? How do you think? Can you compute the parameters under which this trapezoid intersects in this point? It is not very complex, I think. To tell the truth, maybe I will skip this problem because it will take some time to find these parameters. Therefore, excuse me please. This problem is not that simple. I just remembered it. So consider we took a Lipschitz set and we can make a deformation of a Lipschitz set. Do you understand this? Yes, so the problem will be to find first to find the, so we have some kind of angle alpha, we also have this coefficient q. Yes, then this coefficient is easy to find, and after that we can find these lines. They are the same. Again, there is a symmetry, so these lines will be symmetric. So there will be two parameters of which this fractal set depends. It depends on q and alpha, because these points are defined by these parameters, and after that all the other points. One very important theorem. Suppose we have a regular polygon with the side 1, and which has n sides. How to write the rotation of this polygon, which toggles its vertices? This to this, this to this, this to this, this to this, this to this. So it will be a rotation in the angle 2 pi divided by n, yes? But this point is not 0, so it will be, it can be expressed in the following way. First, we rotate it to 2 pi divided by n, then we get this polygon, and translate it by 1. So this rotation of this polygon can be written in the following way. We have rotation in 2 pi divided by n, and translation by 1. It's just in case, because we need to rotate the square, but the formula is good for any regular polygon with n sides, provided the sides are equal to 1. Okay, so now we have this picture. Yes, we can define this map. After that, we can rotate this map to these 4 points, and also we need to define this map. But to define this map, we need to understand what are the coordinates of these points. What are the coordinates of this point? If it is q, this is also q. Can you tell me what is the coordinate of this point? So it's a q, it's q cosine alpha, and this is a q sine alpha. So q multiplied by cosine alpha plus sine alpha. This will be the first coordinate, and the second, you see what it is. Q multiplied by so minus sine alpha, this one, yes, this is cosine alpha and this is sine alpha. So Q multiplied by cosine alpha minus sine alpha. If alpha is rotated by in a so am I right? Q cosine alpha plus sine alpha, yes. And this is Q cosine, and this is Q, the coordinate is Q cosine alpha minus sine alpha. Okay, so I just checked. So having these coordinates, it's easy to construct this picture. I switched it off. Yes, because it shrinks the screen and I cannot see anything in my. I will switch it on again. So you saw some pictures, right? Oh, they are still here. Still here. There are 5 versions of an option. So this problems will be distributed at the end of today, and you have to prepare them till tomorrow. So if you wish, we can take one option and make a solution of it. How do you think? Will it be good? And 4 options will be distributed between you. Because we need to have an exam, and this will be a nice, very nice exam. Okay. So look at the first problem. So construct such a zipper. Are you able to do this? How to construct such a zipper? Construct a zipper and find its dimension. I think you can easily find it. So is it visible? Are you able to do? Let us check. Let us check your ability to make this assignment. Yes, you see. So first, construct the zipper. You see. So we have a polygonal line, and you need to construct a zipper. Construct the attractor of a zipper, but if you look attentively, you can say what is the dimension. So you need just to write down these mappings, yes, and then implement it in IFS style. And you can think that this is 1 and this is 1/3 if you wish. But if you wish a more complicated version, then you can make these sizes different. A, B, 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 A. And you can choose the sizes of the sides, and you think it's not interesting? How do you think? Is it good? Not very complicated, but not very simple, yes? I think there must be a kind of golden middle. I don't know where to choose, to build, to construct, or to plot. You are better expert in English because you use it every day. So which? Build, construct, or plot? What word is better? Construct. Thank you. You helped me. And here we'll also, I need to do you have any questions?
Sir, what are the length we choose, like you are saying?
There are two options. First option is 1, 1, 1, 1, 1.
Yeah.
It's very good.
Yeah.
Yes. I switched the generator of random numbers and found a random sequence 1, 1, 1, 1.
Yes.
Okay. And the other option is A, B, 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 A.
Okay.
In that case, you have a great variety of parameters to You need some assistance? You got the result? Oh, you don't need this. Of course, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 2, 1. And yes, but if you have, you see, in this case, all these maps are not contractions, because they send unit interval to unit interval, yes? And the program will block all your efforts. It protests because it uses only contraction maps. So if you write 1/3 in front of this operator, then it will be okay. So if you have here 1, 0, and 1, and here 1/3, 1/3, 1/3, 1/3, then it will be okay. Yes. The other way needs computation. If you have, say, A, B, 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 A, then you will have you have two possibilities. First, you consider the case when 2A plus B equals 1. right? And you can use SIM. In that case, everything will. The other way, if you just consider these similarities, you have this contraction ratio will be A divided by 2A plus B, and this contraction ratio will be B divided by 2A plus B. So without some additional calculations, you won't have success. So in the case when you have 2A plus B equals 1, it's very good. Then you have, it will be 0, this will be 1, this will be A, this will be A, and this will be 1 minus 2A. And you have you can change the parameter A, but B cannot be independent. You have only one parameter. Yes. Sorry. This is good, and you can absolutely, very good. So whatever you like, you can change the parameters, or you can make this way, A and B, right? Okay, and change A, and it will transform. What? It's okay.
Changing to the random ones.
Yeah.
A and B.
A and B, but you have A and 1 minus 2A. B is 1 minus 2A, but in that case,
I have taken A from 0.1 to 0.4. Is it okay?
A is taken from
0.1 to 0.4.
0. Even 45 will be 0. But not 0.5 is also good because you will get the interval. What? What? You constructed it?
Yeah, how to do that?
How to do this? You have this fractal square is 4 by 4, right? So you have numbers 0, 0, 1, 0, 2, 0. You see, I was not very careful and I didn't explain very well what is the equation of a fractal square. So fractal square has an equation k equals d plus k divided by n, where n is the number of sides. Yes, and d is the family of coordinates of these vertices. Yes, of these corner points. Yes, this is the D. D. What is the D in this case? So this is 0, 0, 1, 0, 2, 0, right? Then 0, 1, 2, 1, 3, 1. Then 0, 0, 2, 1, 2. And finally it will be 1, 3. Yes? How to write it in a program? I will show you it on some other example. For example, let us have a fractal square of this side 1/3, and which consists of this 5 squares, right? You see. So D will be 0, 0, 0, 0. I will write it in square brackets. Then it will be 1, 0, 1, 0. Then it will be 2, 0, 2, 0. Then it will be 1, 1, 1, 1, 1, 1. And this will be 1, 2, 1, 2. 1, 2. So this is D. You can just write it this way, D. So this combination of translations can be denoted by D in your fractracer program. And then you write K is equal to 1/3 combined with D and with K. This is all. What?
Then K is equal to D plus K by N. What is that?
Sorry.
You have written D plus K by N.
D plus K by N, it was a definition of a fractal square, but if I process to the IFS style program, yes, I replace D by a composition of translations. These are translations, yes. I take the composition union of translations, yes, and apply it to K, and then divide it by N. So this operation is just written in this form, but this is the same. So there is a Telegram group for discussion of IF style, IFS style fractracer. It was my dream to make something with fractracer, but I couldn't. So you can join this group and discuss different things, yes. Do you see it? Yes. This group, it is not, is it visible here? Yes. Oh, here it is. There is a link. Very complicated link. I will write it. The link is don't miss any letters. Yes? Okay. So all the news are here. What? This is. Oh, this is good. Yes, and you change the parameter. Mm-hmm. What?
It is the D, means KC you have written there, K equal to 1 by 3 star P star T.
So D here. So you mean what is this D? What you? So when you finish this second, and then there will be third assignment to construct such a fractal composed of triangles. It is very simple. So when you manage with these three problems, I will continue to explain the open set condition because I didn't finish it in the morning, and maybe I will.
This square, can you just scroll down? I think
Yes. Oh, is it okay? Yes, it is. You need to put the battery.
Oh, battery is working.
Working. Yes.
Now speak.
111.
Okay, now okay.
Oh,
Okay.
yes.
Yes.
But lamp doesn't show itself. Yes. Okay. So did you make it?
Yes, sir.
Wow, fantastic. Very good. So if everyone has made it, then we'll proceed to some other things. Tea break in 10 minutes. 3 p.m. 1 second. I need to consult. 3 to 3:30. Oh. Yes. It's okay. Please. No problem. Just switch off the camera and we'll